Welcome to the e-learning modules for airline equipment. This course consists of 3 parts. In part 1, we will start with an overview of the types of airline equipment and their functions. We will also explore the construction and working principles of aftercoolers and air tanks, as well as air tank regulations. In part 2, we will explore air filters, and in part 3 air dryers. Here are your learning objectives. By the end of these airline equipment modules you will understand the types of airline equipment and their functions. We will examine the order in which the equipment is installed and the types of impurities that can be removed. You will also understand the construction and working principles of airline equipment, for which we will use animations to explain the construction and working principles of each piece of equipment. And you will come to know SMC's product line for airline equipment when we will review the different series and their specifications. Here are the contents of Part 1. 1. The types of airline equipment and their functions in a system. 2. Aftercoolers, functions, construction, working principles and product line. 3. Air tanks, functions, construction, working principle, product line and regulations. First, we will look at the types of airline equipment and their functions in a system. Airline equipment on the power source side removes impurities from compressed air, preparing it for use on the equipment side. First, the compressor takes in atmospheric air from the surroundings and compresses it to produce compressed air. However, this compressed air becomes very hot due to the heat of compression. Atmospheric air also contains impurities, which are taken in and concentrated together with the air, making the compressed air contaminated. If this compressed air is supplied to the equipment side in this state, it could cause failure, so the impurities must be removed appropriately. Therefore, an aftercooler, air tank, main line filter, and air dryer are installed, in this order, on the power source side. Next, we will examine what kind of impurities are removed by airline equipment. This diagram shows the sequence of air preparation equipment on the power source side. The chart below indicates the impurities removed by each piece of equipment. First, let's examine the sequence as far as the air dryer. The main line filter removes solid foreign matter particles of 1 micrometer and larger. Removal of water vapor, or dehumidification, is performed by the aftercooler, air tank and air dryer. Only the air dryer can forcibly dehumidify compressed air at room temperature. This equipment, up to the air dryer, forms the basic system. If the application requires high purity compressed air with even finer particles of foreign matter removed, a mist separator and a micro mist separator may be installed and used in stages, depending on the application. If odor removal is required, an activated carbon filter may be installed. We will now examine the details of each piece of equipment in turn, starting with the aftercooler. The compressed air discharged from the compressor is extremely hot due to the heat of compression. This is why an aftercooler is installed on the secondary side of the compressor. Using the aftercooler, compressed air is cooled to around 40 degrees Celsius to protect secondary side equipment and workers. At the same time, this temperature change removes water vapor from the compressed air by condensing it into water droplets. These are the functions of the aftercooler. This method of turning water vapor into water droplets by lowering the temperature is similar to a familiar phenomenon. In winter, condensation sometimes forms on the inside of windows. This happens when the indoor air is cooled by windows that are cold from the outside air, condensing water vapor into water droplets. This method of condensing water vapor into water droplets by lowering the temperature is also used in refrigerated air dryers. Details will be explained in Part 3 of this course. Next, we will explore the construction and working principles of aftercoolers. There are 2 types of aftercoolers, air-cooled and water-cooled. The air-cooled type uses a fan to cool the air. The water-cooled type uses water to cool the air. Let's look at an animation of each type. First, we will examine an air-cooled aftercooler. The red-colored air represents high-temperature compressed air. When the hot compressed air flows through the fin tubes in the aluminium plate, it is cooled by air, blown by the fan. This construction means there is no need for cooling facilities such as cooling water. Another feature of this type is its easy maintenance and installation. One disadvantage is that it is easily affected by the installation environment, because it cools using air. This means it does not perform well in environments with a lot of dust or foreign matter, or in poorly ventilated locations with high temperature and high humidity. It also requires a power source for the fan. Next, we will examine a water-cooled aftercooler. The red-colored air represents high-temperature compressed air. This compressed air flows around tubes that contain cooling water circulated through them. These tubes have a flower-finned tube construction, providing a large heat transfer area that produces a high cooling effect. Cooling water is supplied from an external source and circulated around the tubes. This setup requires cooling facilities such as a cooling tower or thermochiller. To ensure a constant supply of cooling water, users must take measures against disruptions to the water supply. Additionally, water quality control is necessary to prevent scale buildup caused by calcium and silica deposits in the cooling water. Unlike an air-cooled aftercooler, the water-cooled type is not affected by the installation environment, offering stable performance as an advantage. Next, we will look at SMC's product range of aftercoolers. This table also summarizes the differences in features between the two types. SMC offers two types of aftercoolers, the air-cooled HAA series and the water-cooled HAW series. The air-cooled type, which uses a cooling fan to blow air, can be used simply by supplying power. However, since it uses atmospheric air, it is not suitable for high-temperature environments or environments with a lot of dust or other foreign matter. The water-cooled type, which cools by circulating cooling water, requires a cooling water supply, as well as water quality management and measures against water outages. However, it provides stable performance, unaffected by the surrounding environment. The water-cooled type can handle inlet air temperatures up to 200 degrees Celsius, except for the small type with a flow capacity of 1000 liters per minute or less. Thus, the features of aftercoolers differ depending on the cooling method. Users should select the appropriate model to suit the operating conditions at their production site. In this section, we will look at air tanks. By storing compressed air, an air tank performs three functions. The first is to prevent pulsation of the compressed air. The second is to prevent pressure drops due to temporary high consumption. The third is to separate out moisture and foreign matter from the compressed air. Let's look at each of these functions in turn. The first function is to prevent pulsation. In the process of generating compressed air with an air compressor, a phenomenon called pulsation occurs. This means the pressure repeatedly fluctuates up and down. If the air flows to the secondary side in this pulsating state, the pressure cycle will increase the load on the equipment, which will accelerate the deterioration of equipment and make the operation unstable. As a measure against this, the pulsation is equalized using an air tank. The second function is to prevent pressure drops. Compressed air can be stored, and an air tank acts as a reservoir to store compressed air before it is used by various equipment. The air tank equalizes pressure drops caused by momentary high consumption by the equipment. Now, let's see what would happen without an air tank. When the equipment is in operation, a pressure drop occurs corresponding to the amount of compressed air consumed. Next, let's look at the effects of installing an air tank. The pressure drop is mitigated by the supply of the compressed air stored in the air tank. The third function is to separate moisture and foreign matter from the air. If the ambient temperature around the air tank is lower than the temperature of the compressed air inside the tank, water vapor condenses into water droplets due to the falling air temperature caused by natural heat radiation. Additionally, foreign matter naturally precipitates and falls to the bottom of the air tank. Thus, the air tank helps to separate out moisture and foreign matter. Next, we will look at the construction and working principle of an air tank. At the bottom of the air tank, there is a drainage outlet with an auto-drain valve. Because a large amount of energy is stored inside the tank, a safety valve must be installed. The safety valve is a safety device that protects the air tank. When the set pressure is reached, the valve automatically opens to discharge excess internal pressure, and when the pressure drops to a certain value, the valve automatically closes. The appropriate safety valve is used depending on the maximum operating pressure of the tank. After calculating the amount of air flowing into the air tank, a safety valve with a suitable specification is supplied with the air tank. This must be installed by the user. It must always be installed vertically to ensure proper operation. The safety valve is not a maintenance part. Note that it cannot be supplied separately. A pressure gauge is installed to check the pressure. Note that the permissible operating fluid temperature of the air tank itself is up to 100 degrees Celsius, but the permissible operating fluid temperature of the pressure gauge is up to 45 degrees Celsius. Next, we will look at the product line for air tanks. SMC's product range includes the AT series large air tank and the VBAT series small capacity air tank. The capacity of the AT series ranges from 100 liters to a maximum of 3,000 liters. This is a freestanding tank, as shown in the photo. The VBAT series can be used with the VBA booster regulator directly connected. Next, we will look at regulations for air tanks. When using air tanks, users must comply with the regulations in each country. The AT series complies with Japanese regulations for Class II pressure vessels. It cannot be used outside of Japan. Class II pressure vessel regulations are important in Japan. If a container meets certain conditions, it is classified as a Class II pressure vessel and is subject to annual self-inspection. This applies to containers storing air at a pressure of 0.2 megapascals or higher, and meeting one of the following conditions. The internal volume is 0.04 cubic meters or more, or the inner diameter of the body is 200 mm or more and the length is 1000 mm or more. These regulations apply to the AT series. A certificate is sent separately after the product has been delivered. Users must keep this certificate in a safe place. Please note that this regulation applies also to air cylinders and air preparation filters as well as air tanks. For example, it applies to CS1 and CS2 series air cylinders with a bore size of 180 mm or larger, if the stroke exceeds the value shown in this table. This regulation also applies to the mainline filter ALE211 Here is a summary. Airline equipment removes foreign matter and moisture from compressed air, preparing it for use on the equipment side. An aftercooler, air tank, mainline filter and air dryer are installed in this order. Additionally, depending on the application on the equipment side, a mist separator, micro mist separator and odor removal filter may be installed in stages. The aftercooler cools hot compressed air to around 40 degrees Celsius and removes water vapor by condensing it into water droplets. There are two types of aftercoolers, air-cooled and water-cooled. The air-cooled type is easy to install, while the water-cooled type can handle inlet air temperatures up to 200 degrees Celsius. An air tank stores compressed air to prevent pulsation and pressure drops, and it separates moisture and foreign matter from the air. SMC's air tanks range in volumes from 5 liters to 3,000 liters. The largest air tank, the AT series, can only be used in Japan. It is classified as a Class II pressure vessel. Thank you for completing this module on airline equipment part 1. Now, please check your knowledge with a quiz.